more examples for you. So let's see. The very first example here, you have 2 rows and 3 columns. So you have a 2 by 3 matrix, and here you have 3 rows and 3 columns. So 3 by 3 matrix. So note that since 3 and 3 are the same, the number of columns of the first matrix is the same as the number of rows of the second matrix. You're allowed to continue. So what are we going to do? We're going to find the dot product between these 2 vectors first. Okay, let's go. And the outcome is a 2 by 3 matrix. So we expect to have 2 rows and 3 columns. So 1 times -2 plus 0 times 1 plus 3 times -1. This guy is equal to -2 plus 0 minus 3, which is -5. So the very first element is -5. So I'm going to erase this. I'm going to find the dot product between the first vector and the second vector here. So 4 times 1. Or 1 times 4 if you want to keep the order. It's not important, but 0 times 0 plus 3 times 1. This guy is 4 plus 0 plus 3, which is 7. Now, again, we stick to the first row, but we move to the last column, the last vector. So here we have 1 times 2 plus 0 times 0 plus 3 times -1, 2 plus 0 minus 3, which is -1. So this is your last element. Well, now we're going to move to the second row or second vector here. We're going to take this vector and find a dot product with the rest of these vectors. So 2 times -2. Let me write down the whole thing, keep forgetting. And plus -1 times 1 plus -2 times -1. This is -4 minus 1 plus 2. Here you have -2 plus 1. I'm sorry, minus 1, so you get -3. And so here you have -3. So let us move on to the next one. And the last row and the second column. 2 times 4 plus -1 times 0. Plus -2 times 1. This is 8 plus 0 minus 2, which is 6. And then we're going to take the last row, the last vector down here, and find a dot product with the last column here. So you have 2 times 2 plus -1 times 0 plus -2 times -1, so you have 4 plus 0 and plus 2, which is 6. So as you can see, you have a 2 by 3 matrix. Let's move on to example B. The same process. First of all, you have a 2 by 2 matrix. A 2 by 2 matrix, the number of columns of the first matrix is the same as the number of rows of the second matrix. So you're allowed to find the product between these 2 vectors. And note that you are going to have a 2 by 2 matrix. Just pay attention to the identity matrix. Matrix 1, 0, 0, 1 is your identity matrix. So here we're going to have a 2 by 2 matrix, right? The very first row, dot product with the very first column. 3 times 1, 3 plus 0 is 3. The very first row, dot product, the second column. 3 times 0, 0 plus 4 times 1, which is 4. Then we move on to the last row. -2 and 5, dot product with the first column. -2 times 1 plus 0, -2. And you're going to do the same process between the last row and the last column. -2 times 0 plus 5 times 1, 5. You have a 2 by 2 matrix, which is exactly the same as the original matrix. So A, I, is equal to A itself. I represents identity matrix. If I multiply any matrix by identity matrix, it's going to be the same as the matrix itself. If you multiply your matrix by identity matrix from left, it's going to be the same thing, IA. What do I mean by that? It means that I can write it this way. 1, 0, 0, 1, product with 3, 4, negative 2, and 5. They're going to give you the exact same matrix back. And finally, let's take a look at this guy here. 2 by 2 matrix, 2 by 2 matrix. The outcome is going to be a 2 by 2 matrix as well. So the very first rule, dot product, the first column, or the dot product between these two vectors. 1 times negative 1 plus 2 times 0, which is negative 1. Then we'll move on to the second column. 1 times 2 plus 2 times negative 1. This is just 0. And let us move on to the second row. 1 times negative 1 plus 0, negative 1. And then the last row and the second column. 1 times 2, 2 minus 1, 1. This is your new matrix.